Right guys, it's ALSCNC Workshop. Today we're going to be discussing issues that I see on the FoxAlien Facebook group. Seems to be the same questions asked over and over and over again. People are buying desktop CNCs, they're whacking them on a table in a garage. They're expecting them to just do everything that they've seen other people do. It doesn't work like that. It's a learning curve right from the start. Understanding your machine, understanding materials and environments that these machines have to work in. The hardest things, which I'm going to explain today, I've got a list of 8 things that need to be addressed on any machine. So let's go through the first one. So number 1, static. Static's the biggest issue with a desktop CNC machine. There's no suppression built into the control boxes. There's no noise protection from the electrics or anything like that. So you have to put it on yourself. So sparks from routers. I see a lot of people use trim routers. Trim routers are brushed, and when they're put under load they spark, and they spark quite a lot. You may not see it, but it's sparking like merry hell inside. That's creating issues with your electronics. The other issue is earth bonding. So if you don't earth bond your machine, your hoover, your any other accessories that are there on your machine, you're going to get a lot of static build-up, especially off the dust extractor up there. Mine's fully earthed, the machine's fully earthed, the VFD is fully earthed. I haven't had any troubles with it since doing that. You still get some static build-up on the hose because there's a plastic hose, there's no metal in it to earth it, so you're never going to get rid of every bit of it. So static is your biggest issue to get rid of. So eliminate as much static as you can. Right, so that's number 1. Number 2, electrical noise. A lot of people don't understand that when things are drawing lots of power, and no, these don't, but if you've got like a router or a spindle that's running at fair rate of knots, it produces what they call electrical noise. So put in ferrets on all your electrical cables, top and bottom, doesn't matter, you can put as many as you like on it. It just reduces static in the cable, it reduces noise from the electrical supply, and your USB cable should be a shielded USB cable from your computer to your machine, because that is transferring lots of information very quickly, and that creates noise. Right, interferes with your control box. Machine stops. You go, why did it stop? Because of electrical noise. That's why. So that's number 2. Number 3, cold weather. So here in the UK, the weather's either steaming red hot or chucking it down with rain. So we have an issue with damp, cold, damp, wet days. And if you're like me, you're running out of your garage, it gets quite damp in here. So what I do to eliminate all them problems: 1, I make sure my computer's started up and running before I turn the machine on. 2, turn the machine on, all the controls, everything, for an hour before I use the machine. I have a diesel heater in here. I set it to 25 degrees. I get this room to 25 degrees. As you can see, it's insulated, but I haven't done the plasterboarding yet. 25 degrees, get it hot in here. That machine hasn't failed once. with any problems since I've been doing that, make sure that you turn your computer on first. Don't turn your machine on and then turn your computer on, because the connection might not be right. No, I've had issues with that before and it stopped halfway through. So computer on first, guys. So number 4, we've gone over that a little bit. Cold weather and damp. Damp is, like I say, your biggest cause. So number 5, let's go to number 5 because we've covered damp already with 3. A lack of power. Now, lots of people shove these in their garages or in a shed in the garden somewhere, and they've got a small cable coming from the house. It's feeding sockets in your shed, your garage, and it's only going one way. These machines, especially with a VFD or a big 710 watt trim router, it's pulling quite a lot of power. Okay, so what I found is mine was exactly the same, just had one cable coming in and it was feeding loads of sockets. The sockets there for the laser, sockets there for all the other stuff. That's 800 watts. Spindle 1.5 kilowatts. It's pulling quite a lot of juice, and it was running out of power because the lighting system as well is all running on that same cable. So having measured the power in here and measuring the loss, I was determined that that was the biggest issue I had in here, was lack of power. So big cable from the house into the garage, into its own separate consumer unit. This side of the building is powered with a full ring main. The other side of the garage is powered with a ring main, full ring main, and the lighting's all on separate circuits. So we don't have a power issue here anymore. So that's number 5, lack of power. Number 6, computers. So many people, you know, they say, oh, it just keeps crashing, blah de blah, blah de blah. Right, dedicate a computer to your system. You know, it doesn't need to be all singing, all dancing. I tried running my machine on a MacBook. Every time, fail. Get halfway through, bang, stop. And it was starting to get frustrated, and I thought, why is it doing this? The way I discovered, I had an old laptop that was sat doing nothing. So I wiped it and I put software back on it. I put just Windows on it and discovered that there was something not quite right. It was still interfering, but it wasn't quite right. And it turned out I didn't have the right drivers working, you know, whatever Windows pushes in there. So I re-downloaded all the drivers for the cards, you know, the screen and all the rest of it. And it's perfect. It's working. It starts up really quickly. There's nothing else on it apart from CNC stuff. I don't have the internet connected on it. One, because of you get emails banging through. It's trying to update. It's trying to do there. Right, turn your internet off unless you're downloading a file from another part of the building or something like that. But turn it off whilst the machine's running. Interference from incoming messages and stuff like that is going to interfere with your machine and make it stop. Okay. The other thing as well with computers, don't have anything running in the background, and once in a while turn it all off, reboot it, clears the cache out so that it's not bunging all up and it's starting to run really slow and the ports are starting to run slow. Clear it out, clear the cache, job done. No issues ever since. So that's covered computers. So number 7, this is probably the biggest issue that people have, is that they don't understand their machine. They've bought one, it's been delivered, they've put it together, and they're expecting it to just fly out the box, going massively too deep in their material for the machine size. I have the FoxAlien XE Pro. It was a 4040, it's now an 8040. It's got the linear rail upgrade, so it's a bit more stiffer. Like I say, I've got a 1.5 kilowatt VFD on it. It hasn't failed a job, apart from once. There's a bearing shattered on the end of the shaft and it sort of lost itself, but that's machine fault. You know, it's a manufacturing fault. Understand your machine. If it's belt driven, it ain't going to work like that one does. This machine can cut 1/2 inch deep, 2,500 millimeters a minute, 100 inches a minute to you Americans. That's quite scary to see that happening. Don't think I've got the piece that I did, but there is a video on my channel, shows you. It's using the IDC hog bit, 100 inches a minute, 1/2 inch deep, so 12.7 mil. It's scary, it's noisy, but he did it, didn't fail. So expecting it to lose steps. The other thing that people don't understand is if you've got like a Masuta or a Masuta Pro that's running stepper motors that are open looped. So what that means is that the information coming into the stepper motor is being read by the control box. The machine reacts, it does what it's done. It doesn't send any information back to say it's done that step. So with a closed loop stepper motor, sends the information, the machine does what it needs to do, it sends a signal back to say it's done it. It's completed that task it's been asked to do. It happens so fast, what I said about USB cables being shielded. The information moves so damn quick, you know, you can see it scrolling down through your log on your machine's computer, how quickly it's doing those movements. Obviously if you're just doing a straight line, it's just one line of code until it gets to the end, and it'll do another line of code. But if you're doing complex carvings like the Tory hands out there, it's streaming information very, very quickly. So understand your machine, what its capabilities are. You know, a belt-driven machine is going to run nowhere near as quick as a linear railed, ball-screwed machine that's been designed to run at those speeds. This one twiddled. I watched a James Dean video. I twiddled with the acceleration and the speed. I've managed to get the x-axis to run at 6,500 millimeters a minute, and the y-axis, because there's two motors, only at 6,000. With the acceleration I've got, I'm running 1,200 on the acceleration. The standard is 300. This machine, that board there, the face, that told me it was going to take about 6 hours to carve. With the standard settings, it took 2 hours. So take that into consideration. Alter your acceleration. Don't go mad when it starts going. It's because it's under strain and it's losing its information, and it's just going to not play ball. Understand your tools. You know, the manufacturers tell you, yeah, run it at 3,000 millimeters a minute at 1/4 inch deep. Your machine's not capable of doing that. Don't even think about driving it that hard. You know, make sure you've got your path cut in the right way that the tool's spinning. You know, sometimes with V-carve, it'll cut one way, and then on the next part of it, it'll cut the other way. So just be mindful of conventional or climb on your software when you're doing your tool paths. The other thing that people don't understand is that material, hardwoods, I find that they cut a lot easier than say ply or a softwood, because they're quite sticky in terms. You know, they're quite wet. They tend to bog up a little bit, so just be mindful of what material you're cutting, capabilities of your machine, and the software you're running. You know, those are quite essential to understand before you even do any carving. You know, we've all done it. You know, that machine in there is now a laser. That is a little Masuta, just a tiny little one, 60-watt spindle it had on it. You know, I was expecting it to do things, and it's just not capable because the spindle's too slow. So I put a 300-watt spindle on it, massively improved it. And then obviously it's not very big. It's still a 40-40, but it's, you know, not very big. And I changed to the XE Pro. I had a trim router on it. Couldn't bear the sound of the damn thing squealing away, so buy a VFD. They're not that much more money. And one of my other videos shows you setting up the VFD to run off laser socket on the FoxAlien machine. It's a bit of tweaking to do because each one's slightly different, you know, different power and stuff like that. But it's all there, and there's a spreadsheet in the description on how to set it all up. Over that, I'll spend £380 or $450 on the FoxAlien one, which is not coming out until end of September, I believe. So, you know, is an investment worth dealing with. Slightly heavier than that trim router, but it's well worth the investment. You won't regret it. It's quieter. You know, you can hear yourself think. You can hear what the machine's doing. You know, you can hear your stepper motors whirring away, and you know, it's quite satisfying. So that's not understanding the machine's out of the way. So next one, clean tools. Now we'll do it, you know, running your tool, like I said, pine and ply, because there's glue all in that, MDF, all them resins and glues, and even out of hardwood you get natural resins, or tannins or whatever they're called. They stick to your tool faces and they make them go blunt. The tool's not blunt, it's just covered in junk. So either use a tool cleaner that you can buy from any sort of woodworking place that sells woodworking machinery and tooling, or if you've got an ultrasonic cleaner, put them in an ultrasonic cleaner. You can buy little tiny ones off Amazon, big enough to do tools. Well, I've got a big one because they do other things as well as this. Got a bigger one. You wouldn't believe the junk that comes off your tools when you put them in an ultrasonic cleaner. And it's not damaging them in any way. All it's doing is releasing all that glue and all that sticky residue that builds up on your flutes and what have you, which stops the chips from, you know, coming off. This is the IDC surfacing bit. It's crap. Don't buy any of these. Sorry, Garrett, but yeah, it's crap. I used this once and it was absolutely bunged up. As you can see, it's bunged up again because I did some Paduke, surface some Paduke with that. But you wouldn't believe the junk that come off this. These are not very good. I have now managed to source an 8mm collet to go in the VFD, so I can now use the big 1.25" surfacing bit with the 4 heads on it. And again, understanding the tools, you know, don't run a massive tool at 24,000 RPM. It's just going to shake the living daylights out of your machine. Dial it down. Find that sweet spot where it's cutting enough that you want to be able to get a nice smooth surface. No vibration on the bearings of the router or the VFD. So yeah, keep your tools clean. They'll last a long time if you keeping them clean. Once they start burning, you're in trouble, right? So I buy these tools, and all my V carvings being done with these, right? These come off Amazon. They're £8.90, so about $12 for 10. They are bloody brilliant. They cut well, they make a nice clean job of it, and I actually cut 5mm aluminium 6068 with this, right? T5 aluminium with these tools, and using lubricant. Find them on, I think they're called Gas Air or something like that. Cheap. Put them in a tray in the ultrasonic cleaner. You wouldn't believe the junk that comes off them. And I reused it, and it worked. So that's the things to look out for, guys. Don't just buy a machine and expect it to go flying. You know, it's not going to do what you think it's going to do. It's not an industrial machine, it's a hobby machine, but you can make them work for you in the right environments. So that's the 8 points I wanted to get through today about people on Facebook, you know. And the other thing I see is people, touch plates, FoxAlien touch plate, mine's here, right, I stick it on the machine, bam, job done. I measured that, it's 14.89mm. Don't put that in the settings, you're just asking for trouble. Open Builds doesn't recognise points, millimetres, only recognises full millimetres for the touch plate. Fatal mistake I did, I put in 14.89, probed it, press play, bang, straight into the material. Just completely dove in, like right down to the collet. It bloody frightening. Don't do it. It's 15mm. Put it in as 15mm. Mine, 2 layers of tape, as it's going around the edge of this board, shaping this board to the right size. It's taken 1 layer of tape off the machine bed and left the other one. That's how close it is. Don't worry about it. If your machine's trammed properly, levelled and everything, that will just skim that. Leave it. It's 0.1 of a millimetre. Don't. Open Builds doesn't recognise it as points like that on the touch plate. So I just put it all back in as 15mm. Never did it again. There you go. Right, guys, so I don't want to bore you any longer. I just wanted to get these points across because it's the same questions on Facebook. My machine keeps failing, it don't make round circles. Machine setup, right. One thing I haven't covered about getting machines up and running. This particular one has these stupid twisty things on the ends here. When this machine's not powered, you can turn them. So when you get your machine, bring it forward so you can put a vernier on there. It needs to be a vernier because you need to be pretty accurate. Make sure your machine's square and perpendicular. Measure, leave the power off, twist them until they're exactly the same measurement. When you turn one, one will change, so you need to It's a bit of a fiddly farty thing to do it. Turn the machine on, these lock up, they don't turn. But check that every time on lead screws. These things turn. Right? It's not so bad on that end because it's only one motor, but it's this end. It'll be running like that, and then your x-axis isn't travelling. If it's dead straight like that, it's running dead straight. If it's running on the piss like that, so is your cut. And when you're trying to do a circle, machines go and the x-axis is moving, the y-axis is moving, they're out of sync because it's getting wider and narrower. That's why your circles are not circular. You're running it too fast, it's lost a step. Them sort of issues, right? That make sure that that carriage is dead square to the machine. You won't have pissed up circles. Now, I don't think I've ever had a circle that's not been round, because I make sure that I measure down. Alright, that's one thing to take into consideration, is that even the belt driven machines, when it's turned off, you can do that to it. Make sure it's dead square, and the frame's then running dead square when it's running on a circle, or an ellipse or something like that. Even on an ellipse, it'll just run off because it's not right, because one side's further over than the other. It might only be 0.2 of a millimetre, but when you're doing a circle, it's exaggerated into the wood. Alright, so those are the points, guys. Make sure you square, earthed, computer not running any rubbish, and you're good to go. Learn your feeds and speeds. People keep putting up, how much feed and speed shall I put on to do a bit of 1/8 ply? Depends on your tool, depends on the machine, depends on a lot of factors. Don't just ask somebody else for their speed and feed. Get it all the time. What's your feed rate on there? It depends. I can run these quite fast. Don't, because you do lose a bit of the accuracy. 35, 40 inches a minute, 50 inches on the male part, on the female part of it. Don't go mad. Slowly build up. Better to start at the bottom, just keep working up. You go hell for leather, as soon as you press that button, it's either going to snap the tool, knacker your machine, burn out your motors, burn out your router or your spindle, and then you've got, well, it's just knackered, isn't it? It's going to cost you money. Start at the bottom, work your way up. I've had this machine just over a year and I'm still learning. Never stop learning. Don't think you know it all, because one piece of material will come and bite you on the ass and damage the machine. One thing to watch as well, especially in the UK, MDF. It's got bits of stone, bits of metal, all sorts of crap in it. Just be mindful of your material, where you get it from. Ply can have little bits of grit in it that'll blunt your tools off. Just be mindful of all the points that I've made today. Happy CNCing.